So today what we'll be doing is we're going to take a look at factoring quadratic expressions in standard form where a is equal to 1. So let's begin by just quickly talking about what the vertex form would look like when a is 1. Well, for the vertex form, we're literally going to have y is equal to x minus h squared plus k, since a is 1. For the intercept form, we're going to be having something that looks like this. Y is equal to a is 1, and then we have x minus r and x minus s. Now, for making our calculations nicer, in order to see a pattern, we're going to assume that the brackets turn into x plus r and x plus s instead. When we talk about the vertex form, we're talking about this. Y is equal to, if a was 1, we'd have x squared plus bx plus c. Now, on to the lesson. When we talk about the intercept form when a is 1, remember I told you earlier that we were going to make sure that we let our equation be x plus r and x plus x, and we'll see what comes out of that. So when we do this, we're just going to do our FOIL on x, and we get x times x and sx. So just imagine that r and s are like variables. So what we're going to get is this, x squared and then plus sx. Now let's continue with the last half of the problem set. So when we do this, we're literally going to have the following. We're going to have r times x and then r times s. So remember, r is our just straight number. So we're going to get plus rx plus rs. Now, what I want you to remember is that the center variables normally would be added together. So when we do this, we're going to end up with our final equation, x squared plus, if you think about it, that middle part is really s plus r, x, because we just common factor out an x, and then we have plus rs. So essentially, if we have the intercept form, y is equal to x plus r and x plus s. Therefore, the standard form that we have based on that equation is going to be y is equal to x squared plus s plus r x plus rs, where b is equal to r plus s and c is equal to rs. Now just remember standard form is equal to y is equal to x squared plus bx plus c. And we're done. Now, for vertex form, we have something a little more complicated. So let's take a look at that now. If we have x minus h squared, we'll write it as, well, x minus h times x minus h plus k. So now let's distribute just like before. And then these two. So now the blue produces the following. X squared minus hx, and the purple foil will give us minus hx plus h squared, and then plus k. Now what I'm going to do is we're going to take our time and we're going to bring these parts together. So we start with x squared, and we have for the second part negative 2h x plus the final quantity h squared plus k. Now remember, if we start with our vertex form, which is x minus h squared plus k, we come out with x squared plus negative 2hx plus h squared plus k. So remember, our basic equation for the standard form was y is equal to x squared plus bx plus c. So that means our b in this equation is going to be negative 2h. And our last part, c squared, c was just h squared plus k. Now that's confusing. Now, here's the rule. When we expand or convert from intercept form to standard form, factoring is basically taking the standard form and converting it into standard form to intercept form. Basically, they're just opposite processes, and that's what we're going to focus on today. Now, to go from standard form to vertex form, we'll eventually come to that, but right now we can go from vertex to standard simply by expanding. Now remember, anytime we have intercept form, we can go over to standard form by just simply expanding as well. And we'll talk about this 2 or 3 lessons from now. Remember I told you that factoring was just the opposite of expanding? Well, how the heck does that happen? Let's go through this and see if we can find it. Now remember, if we FOIL this bracket x plus 4 and x plus 3, we're going to factor and simplify. So we're going to get x squared plus 3x plus 4x plus 12. And then we end up with x squared plus 7x plus 12. We have just converted from intercept form to standard form. And when we factor, we're actually taking anything that's in standard form, like I say here, and we're converting it into intercept form, like we said in our description in the previous page. So here's how we do this. In order to get these parts of our brackets, our 2 linear brackets that come from this, remember, we have this gives this, and we're trying to go backwards here. We have to think about this that we did before. Remember, we said when we did x plus r, we did x plus r and x plus s, we found x squared plus, the simplified form was r plus s plus rs was our expansion, where this was our b value and this was our c value. So what you need to imagine is, in order to get the b value in our problem, in this case 7, we need to add the r and the s terms from the original brackets. So in essence, we need 2 numbers that add to 7, but also multiply to give the last number in our equation. So we think of all the factors of 12. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So now, the sum of 1 and 12. The sum of 1 and 12 is 13, isn't it? The sum of 2 and 6 is 8. And the sum of 3 and 4 is 7. That's perfect. So 3 times 4 gives 7, but 3 plus 4 gives 7. So that means when we think about what's happening here, we end up with plus 3 and plus 4. And we can use that concept every single time we do these calculations. We always look at the last term by thinking about two numbers that multiply to the last term, but then add to the 7 in the middle. Let's try and apply that rule over and over again till you get it. So let's factor if possible. So when we take a look at this problem here, x squared plus 4x plus 6, you need to think about the factors of 6. In this case, the factors of 6 are 2 and 3 and 6 and 1. Now, the sum of those factors, if you think about it, the sum of those factors are, well, 2 plus 3 is 5, and 6 plus 1 is 7. You'll notice that we're not taking any fractional factors. We're not going to do that. Okay, so one of the things I'm going to tell you is that if I have a positive last term and a positive middle term, that means all my factors are positive. Okay, so in this case, this one is not possible. So that happens from time to time, that you can't factor it. And we do have another way of factoring, but you're not going to do that for now. Okay, so now let's take a look at the next problem here. We have x squared minus 16x plus 15. So I'm going to tell you right away, the moment that I have a positive, something that multiplies to positive 15, but adds to negative 16. So anything that's positive, think about it. For this one, think about it. Positive times a positive equals positive, right? But also negative times a negative also equals positive. You'll notice that the middle term here is negative 16. And from there, I can deduce that I can't have two positive numbers adding to a negative number. So it must be two negative numbers that are going to be added together in this case. So now let's begin. For 15, the possible values of 15 are 15 and 1, but since the middle term is negative, both of them must be negative. We can also have 3 and 5, but both of those must be negative. So negative 15 and 1 is negative 16 when we add them together, and this one here is negative 8. This is what we're looking for. So all we have to write is this. We write x starting both brackets, and then we're going to use minus 15 and minus 1 as our factors. So now let's do the same for the last problem. Pause the video and try this. I'm going to give you a hint. One of them is negative. The question is which one? Can you guess the rule? So when I do these problems that involve a negative last term, I have to think about, I just think about the positive values and I say, okay. The possibilities are 35 and 1 and 7 and 5. But you'll notice that the the end term is negative, so that means one of them must be negative. If I look at the middle term is negative 2x. So the only way you get two of these numbers to add up to a negative is if one of these numbers, the bigger number, is negative. So when we add negative 35 and 1, we get negative 34. When we add negative 7 and 5, we end up with negative 2, which gives us our middle term, which is perfect for what we're looking for. So this is our solution, and we write x, and one of the numbers is minus 7, and the other number is plus 5. And we're done. So now let's take a look at this last problem. This last problem has a GCF to start with. Now what I would tell you right away is to factor the GCF first and then go and do the breakdown that we were taking a look at. So in the first question here, you'll notice that all of these numbers are divisible by 3. So we're going to assume that our GCF is 3, and we're going to pull that out. So we're going to get 3. Then we have x squared plus, well, 9x divided by 3 is going to be 3x. And negative 54 divided by 3 is negative 18. So now that we have something like this broken down, it's only this we're considering. So in this case, we need something. Now, this is how I normally write it. I need something that multiplies to, well, negative 18, but then adds to positive 3. So let's go through the numbers. So the numbers that we have are 18 and 1 right off the bat. We have 6 and 3. But our overall multiplication is negative. So when we look at this, one of these numbers has to be negative for 18 and 1. In order to make our middle term positive, that means our smaller number has to be negative. And then when we're adding again for the the last two terms, because it's positive in the middle, the negative 3 must be right. So now let's take a look. Both of these sets multiply to negative 18, but only one of them add to negative 3, positive 3, and it turns out to be 6 and 3x. Therefore, when we write our final answer, we write 3x, and we're going to use plus 6, and we're going to use minus 3 as our answer. Now, your job today is simple. And you'll notice I left my bracket there and my number in front as well in order to keep the equality. So all I want you to do is to read the key concepts and communicate your understanding on page 240 for all the big ideas in the chapter, right? And then include them in the notes if you feel they're useful. And then what I want you to do is I want you to do all these questions. There is one question that has a little difficulty. I want you to do 16b in the extra challenge by using factoring by grouping. See if you can get it right. Good luck.